Welcome to your Algebra 2 Lesson 3.4. Today we're going to solve systems of linear equations in three variables. So it's important that you've mastered the algebraic methods for solving systems in two variables before you move on to this lesson. Okay, some important definitions. A linear equation in three variables, x, y, and z, can be written as ax plus by plus cz equals d, where a, b, and c are not all 0, because that wouldn't be very interesting at all. A solution of such a system is the ordered triple x, y, z. Okay, there's three cases. There's the one solution case where all three cross in a single point. There's infinitely many solutions. And there is the case 2 where you have no solution. All right. This is much easier done than explained, but here is a stab at being able to explain how to use the elimination method, really algebraic method. It's going to be a combination of elimination and substitution sometimes. We're going to rewrite the linear system in three variables as a linear system in two variables by using the elimination method. So you're going to pick a variable and do some combinations to get rid of that variable until you get two new equations in the same two variables. Then you're going to solve that new linear system of two variables and two equations for both of the variables in it, just like we did in the last lesson. Finally, you're going to substitute those values found in step 2. So you will have found two values for two different variables, and you will plug those into one of the original equations and solve for the remaining variable. Now, two things to keep in mind for special cases. If you obtain a false equation such as 0 equals 1 in any of the steps, then the system has no solution. If you obtain an identity such as 0 equals 0 or 5 equals 5, anything like that that's always true in any of these steps, then there are infinitely many solutions. Okay, so let's look. We're going to solve the system. We've got 4x plus 2y plus 3z equals 1. We've got 2x minus 3y plus 5z equals negative 14. 6x minus y plus 4z equals negative 1. All right, we're going to rewrite the system as a linear system in two variables. So we've got to pick a variable to eliminate. Let's see up here. We've got a negative 1y. Let's get rid of y, because what we can do is we can just take plain old equation 1 and add to that 2 times equation 3, 2 times equation 3, and we will be able to eliminate the y's. So that's exactly what we're going to do. We're going to add 2 times equation 3 to equation 1. So we recopy equation 1, so it's a straight recopy. 4x plus 2y plus 3z equals 1. And then we're going to multiply everything in equation 3 times 2. So 6x times 2 is 12x, and then we'll have minus 2y plus 8z equals negative 2. Now we're going to add these two equations together, and our y's will be eliminated. So we've got 16x, and the y's are eliminated, plus 11z equals negative 1. So this is your new equation 1. All right, remember we're trying to get rid of the y's, so we have to keep going with that idea. Now we've already combined 1 and 3. Let's combine 2 and 3. So we want opposites in front of the y, so I'm going to need to multiply equation 3 by negative 3. That'll change this to a plus and give me 3, and we'll be able to eliminate the y's. So I'm going to add negative 3 times equation 3 to equation 2. So I've got 2x minus 3y plus 5z equals negative 14. That's just equation 2. And here's negative 3 times equation 3. Negative 18x plus 3y minus 12z equals 3. So let's add. And that'll give us our new equation 2. If you want, sometimes I label the new equation 1 1 star and the new equation 2 2 star. And that way I can kind of keep track of them. All right. So 2x minus 18x is negative 16x. Negative 3y plus 3y zeroes out. 5z minus 12z is negative 7z. Negative 14 plus 3 is negative 11. So now we've got new equation 1 and new equation 2 are star 1, star 2. That's usually what I do. And so we've got 16x plus 11z minus equals negative 1. And then negative 16x minus 7z equals negative 11. I look, and if we just add them together right now, the x's will eliminate. Okay, 16x minus 16x zeroes out, which is what we wanted, so that's great. So we get 4z equals negative 12. So now we can solve for z super easy. We just divide both sides by 4 and we get z equals negative 3. Now that we know what z equals, we can take this negative 3 and plug it into either one of the new equations, the start equations, and we can solve for x. Okay. Either one that you plug it into, so let's say I plug it into this one here, I'll get 16x plus 11 times negative 3 is negative 33 equals negative 1. Add 33 to both sides, I'll get 16x equals 32. Divide by 16, I get x equals 2. Now I know that z is negative 3, x is 2. How could we find out what y is? That's right. We're going to take both of these values and plug it into any one of the equations in the original system and solve for y. So let's look at original equation 3. 6x minus y plus 4z equals negative 1. So we're going to have 6 times 2 minus y plus 4 times negative 3 equals negative 1. So that's going to end up giving us y equals 1 because we'll get 12 minus y plus negative 12 equals negative 1. So that'll be negative y equals negative 1. Divide both sides by negative 1. You get y equals 1. So your answer to the whole system would be the ordered triple 2, 1, negative 3. Okay, 2, 1, negative 3. You want to write it as an ordered triple, just like ordered pairs. All right, for example 2, we're going to solve the system x plus y plus z equals 3. And then 4x plus 4y plus 4z equals 7. And 3x minus y plus 2z equals 5. All right, let's see. We could get rid of the x's pretty easily because we have just a plain x here. So let's multiply the first equation by negative 4. And that would give us negative 4x plus 4x. Negative 4y plus 4y. Negative 4z plus 4z is 0. Negative 12 plus 7 would give us negative 5. So 0 equals negative 5 is a false equation, right? You can see there it's a false equation. So that means that we have no solution. Okay, we have no solution. You can either write out no solution or you can use the empty set symbol. All right, let's look at our third example. We're going to solve the system x plus y plus z equals 4. X plus y minus z equals 4. 3x plus 3y plus z equals 12. Well, we're going to rewrite the system as a linear system in 2 variables. Let's see, let's get rid of the z's. That's really easy to do. We have a plus z and a minus z in equation 1 and 2, so we can just add those together. And we're going to get 2x plus 2y equals 8. Okay, now we could add 2 and 3. So we get x plus y minus z equals 4, 3x plus 3y plus z equals 12. Add them together, we get 4x plus 4y equals 16. So we've got our 2 new systems. Remember, I sometimes label them 1 star or star 1, star 2. That way I know the difference between the new equation 1 and 2 and the old equation 1 and 2. So let's see. We would need to add negative 2 times equation 1 so that we have negative 4 in front of x to go with this 4x. So let's multiply everything in the start equation 1 by negative 2. So we have negative 4x minus 4y equals negative 16. Then we have our new equation, 4x plus 4y equals 16. We start adding, and let's see, we get 0 plus 0, which is 0, equals negative 16 plus 16 is 0. So you've got the identity 0 equals 0, so the system has infinitely many solutions because it's always going to give you a true statement. So there's infinitely many solutions. Okay, the marketing department of a company has a budget of $30,000 for advertising. A television ad costs $1,000. A radio ad costs $200. And a newspaper ad costs $500. The department wants to run 60 ads per month and have as many radio ads as television and newspaper ads combined. How many of each type of ad should the department run each month? All right, we're going to write verbal models for this situation. So let's see, TV ads plus radio ads plus newspaper ads equals total ads. And we know that's an important equation because they tell us that they want to run 60 total ads. Well, each TV ad is going to cost us $1,000, so 1,000 times the number of TV ads, plus each radio ad will cost us $200, so 200 times radio ads. Each newspaper ad will cost us $500, so plus 500 times newspaper ads equals the monthly budget. So that's going to equal $30,000. Okay, and then we're also told that they want to run as many radio ads as TV and newspaper ads together. So radio ads is going to equal TV ads plus newspaper ads. So we're going to write a system of equations. We're going to let X be the number of TV ads, Y be the number of radio ads, and Z be the number of newspaper ads. So X plus Y plus Z is 60. 1,000X plus 200Y plus 500Z equals 30,000. And then finally, Y equals X plus Z. Okay, now if you look, we've got Y equals X plus Z, so we can rewrite this system here and here as a linear system in two variables by substituting X plus Z for Y in equations 1 and 2. So here where we have Y, we're going to put in X plus Z. Here where we have Y, we're going to put in X plus Z. So we're going to have X plus Z plus Z equals 60 because we are substituting X plus Z in for Y. So there's our new equation 1, our 1-star equation. Okay, and we get that by doing X plus X is 2X, Z plus Z is 2Z equals 60. We're going to write equation 2, so we're going to substitute, and instead of writing Y, we're going to write in X plus Z, and then we're going to see what we get. So let's see, 1,000 plus 200X is going to give us 1,200X. 200Z plus 500Z is 700Z equals 30,000. So that's our new equation 2, our equation 2 star or star 2, however you want to think of it. All right, we're going to solve the linear system of two variables. So let's see, let's go back here. Oh, I might as well get rid of the x's, so I need to multiply this first equation by negative 600 so I can get negative 1,200 in front of x. So we're going to have negative 1,200x minus 1,200z equals negative 36,000. And we're going to add to that 1,200x plus 700z equals 30,000. And so we get negative 500z equals negative 6,000. So how do we solve for z? That's right, we divide by negative 500. So z equals 12. So now we want to find out what x equals. So we need to plug back into one of our systems of our equations with just two variables. And you're going to end up with x equals 18. And once we have x equals 18, we take the x and the z, and it's probably going to be easiest to substitute it into the y equals equation, and you're going to, the y equals x plus, or the y equals, x plus z, and so it's y equals 18 plus 30, 18 plus 12, which is 30. So our solution here would be 18, 30, 12, if we write it as an ordered triple, or 18 TV ads, 30 radio ads, and 12 newspaper ads. Okay. There we go. All right. Thank you so much. Thank you for watching the video and taking good notes. Do the problems to try on your own. Try to do them correctly. That's how you solidify your learning. Bring your notes with you next time to class. I will see you then. If you need help, come in and see me or watch the video again. Y'all have a good day. I'll see you soon in class.